Hello students, I hope you have all been keeping well. Today we will learn another new unit that is from chapter 3, Earth's Movement and Major Landforms. This is from your Geography section. In this lesson, we will try and develop an understanding of the Earth's movement and the resulting landforms. So let's begin with the class. The contents for this unit are forces changing the Earth's surface, earthquakes, and volcanoes. Under each topic, there are several other subtopics, so we will discuss about each subtopic one by one. This is the structure of the Earth, that is the interior of the Earth. We have the crust, which is at the topmost layer, then we have the mantle and the core. The Earth's mantle is a region where heat is circulated and distributed, due to which intense energy is produced. The Earth's crust, as we already know, is lighter and floats on the molten mantle. The intense energy produced due to the heat causes movement of the Earth's crust. This causes periodic changes in the face of the Earth. What makes our Earth dynamic even though it appears quite stable and still? Well, there are forces on the surface and underneath it that are constantly at work. These forces, we know it as exogenic forces and endogenic forces. They are continuously changing the face of the Earth. Some of them help to build the land while some destroy it. These dynamic processes of the Earth are modified and they are supplemented, meaning something is added in order to complete it. We have the climate change, sea level variations, and natural disasters like earthquakes, landslides, floods, tsunamis, droughts, and cyclones. What the Earth looks like at present is the outcome of all the changes that have taken place over millions of years ago due to these particular movements. The Earth is constantly being reshaped by the agents of running water, sun and rain, wind, glaciers, and waves. This caused the present landforms to be varied and diverse. There seems to be a jigsaw fit between the continents. Most scientists believe that millions of years ago there was a supercontinent called Pangaea, which in the Greek language means Old Earth. Alfred Wegener, a German meteorologist, proposed that the 7 continents acquired the present shape over a long geological period by slowly drifting apart from the supercontinent called Pangaea. Moving on to the first topic, that is forces changing the Earth's surface. Moving on to the two forces affecting the Earth's surface, that is exogenic forces and endogenic forces. Exogenic forces are those that act on the Earth's surface, such as wind, water, ice, temperature conditions, etc., and modify the face of the Earth, whereas endogenic forces are those which act beneath the Earth's surface. They may be either slow and gradual, like the forces involved in the process of mountain building and continent building, or quick and sudden, like earthquakes and volcanoes. Plate movements. According to scientists, the Earth's crust is divided into 7 main lithospheric plates. These float on the mantle and are constantly in motion, that is, they are constantly moving. The circular heat currents that are generated in the core that causes the molten rock in the mantle to move. This accounts for the movement of lithospheric plates. The movement of the Earth's lithospheric plate is termed as tectonic movements. Tectonic movements are divided into 2 types, that is, horizontal and vertical movements. Horizontal movements. These movements produce forces of tension and compression. These forces causes faulting, and folding in the Earth's surface. Folding is the pressure of converging plates causing the crust to fold and buckle, resulting in the creation of mountains and hills. In the left picture, you can see the horizontal strata of the Earth's crust before folding. In the right picture, you can notice the compression from the forces shorten the crust of the Earth, thus forming mountains. You can also see the anticlines and synclines. Anticlines are upfolds where rocks are pushed upwards, whereas syncline is a downfold where rock layers are bent in a downward motion. Large-scale folding of the crust results in the formation of a series of mountain ranges called fold mountains. Here in this picture is an example of the Himalaya mountain range in Asia. Here is another example of a fold mountain. This is the Andes Mountain of South America. The Rocky Mountains of North America and the Alps of Europe are examples of fold mountains. Faulting of the Earth's crust. Faulting is where cracks in the Earth's rocks are created because of different movement of tectonic plates, where plates move away from each other in both vertical and horizontal directions, as you can see in the picture. Faulting can be compared to like that of an elastic or a rubber band when you stretch it until it snaps. Similarly, when these blocks of land are stretched from two opposite directions, they break apart and get dislocated from the original location, forming deep faults. Here are some examples of faulting. Such forces that act on rocks from two opposite directions are called tensional forces. Vertical movements. These movements are caused by forces that uplift the Earth's crust or cause its gradual caving or sinking. Vertical movement causes the crust to get uplifted. These forces forms valleys and plateaus. Plate movements may be summarized as the follows. We have three different types of plate movements. Firstly, we have the convergent plate movement. Second, divergent plate movements. And lastly, transform plate movements. Convergent plate movements are a result of compressional forces which cause the plates to collide against each other. This results in the folding of the Earth's crust to form mountains. Divergent plate movements are a result of tensional force that pull these plates apart. This creates huge fault between plate boundaries through which magma flows out. New oceanic crust forms when hot molten lava slowly cools and solidifies. Due to the pull of these plates, the crust in the mid-oceanic regions is very thin. Transform plate movements takes place when two plates slide past each other, causing immense friction occurs resulting in devastating earthquakes. Now we have the next topic, earthquakes. Have you ever experienced the sudden shaking of the ground, which we know it as earthquake? You may have experienced it yourself or you may have seen in the television. So now, let us learn more about earthquakes and see where it occurs and how does it occur. Where do earthquakes occur? Earthquakes are most common in regions that are prone to faulting. Faults occur when two plates meet, as we have already understood in the previous topic. Earthquakes usually originate deep from within the Earth's crust, where pressure between two plates is so great that they cannot be held in place. Due to the release of pressure, the rocks inside the crust snap, sending shock waves or seismic waves out in all directions. The point inside the Earth where the earthquake originates is called the focus, as you can see in the picture here. The point on the surface that is vertically above the focus is called the epicenter. Measuring earthquakes. The Richter scale measures the strength or intensity of the shock waves produced by an earthquake. Richter scale magnitudes are based on a logarithmic scale with base 10, as you can see in the following picture. An increase of one numeral on the scale would represent 10 times of the magnitude, meaning the more higher the numeral, the more stronger the earthquake. For example, if an earthquake measures 7.0 on the Richter scale, then it is 1,000 times more powerful than an earthquake measuring 4.0. An earthquake that measures below 4.0 on a Richter scale does not cause much damage, but an earthquake of 7.0 would result in widespread disaster. An example of the earthquake that occurred in 2015 in the month of April in the place of Nepal had a magnitude of 7.8 or 8.1. That resulted in a disaster because it killed almost 9,000 people and injured 22,000 people. It is difficult to predict when an earthquake will occur. Through regions most at risk can be identified. To minimize damage caused by earthquakes, various measures can be taken to make buildings and structures earthquake resistant. Moving on to the final topic, that is volcanoes. Volcanoes. A volcano is an opening or a vent in the Earth's crust through which molten magma, ash, and gases come out from below the surface. Volcanoes are generally found where tectonic plates converge or diverge from each other. The best example of convergent tectonic plates is the Pacific Ring of Fire. The example of divergent tectonic plates is Mid-Atlantic Ridge. Volcanoes can also form in places where the Earth's crust is subjected to stretching and thinning, such as in the African Rift Valley, as you can see in the particular picture. Volcano eruptions occur in subduction zones, which are created when two plates, usually an oceanic plate and a continental plate, collide. The oceanic plate is overlapped by the continental plate, forming a deep ocean trench just offshore, meaning a long narrow ditch. Types of volcanoes. We have three types of volcanoes. Firstly, we have active volcanoes. Volcanoes that erupt frequently are called active volcanoes. Next, we have dormant volcanoes. Dormant volcanoes that have not erupted for a long time but have chances of erupting in future are called dormant volcanoes. Extinct volcanoes that are volcanoes that have not erupted for at least 10,000 years and are not likely to erupt at all. This is what we understand as the extinct volcanoes. Most of the active volcanoes in the world lie in the Pacific Ring of Fire belt, which lies along the Pacific coast. Mount Etna in Italy is an active volcano. An example of dormant volcano is Mount Vesuvius of Italy. Here in this picture we have Mount Kilimanjaro, which is an example of an extinct volcano. Hotspots. Hotspots are usually located where the heat of the Earth's mantle creates a column of hot molten material that rises up until it reaches the crust, that is the surface of the Earth. The temperature melts the rock in the crust, forming pipes through which magma can be released to the surface. The Hawaiian Islands have many such volcanoes. Before we wrap up with the chapter, as we have come to an end, let us watch a video in order to revise and to have a better understanding of the unit.
Our planet is in a constant state of motion. However, if we take a look just below the surface, we find that things are always moving below our feet as well. It's called plate tectonics, and it's how the continents were formed and reformed and reformed. But before we get to that, let's dive underground to learn what our planet looks like from the inside out. Our Earth is made up of layers, and there are two types of layers we need to learn about in order to understand plate tectonics. the compositional or chemical layers, and the mechanical layers. We could spend an entire session on what makes both of these types of layers unique, but for this lesson, we're simply going to provide an overview. There are three primary compositional layers to the Earth's surface, and these are probably the ones you're most familiar with: the crust, the mantle, and the core. It's important to understand that the compositional layers refer to the materials or elements the Earth is made of. However, if we take a look at how the inside of the Earth behaves, we can divide them even further into mechanical layers. Starting from the outside working in, the lithosphere is the outermost layer of the Earth, which contains the entire crust and the topmost layer of the mantle. The asthenosphere contains the same materials as the top layers of the mantle, but the pressure and the heat are increased. It's not exactly a liquid, but it does move like heated rock, so you could say it's somewhat fluid. The mesosphere is next. At this level, the pressure is really starting to build, which restricts the molecule's ability to move, thus making it very, very rigid. Past the mesosphere is the liquid outer core. Extremely high temperatures melt the metals contained in this layer into liquid form. Think flowing rivers of lava, and you'll have a pretty good idea of what the outer core is like. And finally, we reach the solid inner core. Just like the liquid outer core, the inner core has extremely high temperatures and is composed of mostly metals, which might lead you to ask, why isn't it liquid as well? The answer is pressure. There's so much pressure at this depth that even though the temperatures are beyond the melting points of the metals contained in the inner core, the high pressure essentially squishes everything down into a solid. Now that we know a bit more about the composition of the Earth, let's move on to plate tectonics. Let's start with the history. In the early 1900s, a scientist named Alfred Wegener noticed that the coastlines of several continents looked like they fit together, similar to puzzle pieces. He believed that around 200 million years ago, all of the continents were joined together in one large supercontinent that he called Pangaea, which is Greek for all the Earth. Over the course of millions of years, Pangaea broke apart into the continents we know today, a process he called continental drift. Although his theories explained quite a bit about the origins of the Earth, scientists at the time weren't exactly impressed and initially dismissed his ideas. Fast forward to today, and Wegener's concepts are the basis of the modern-day plate tectonics theory. So what exactly is the plate tectonics theory? Well, it states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are constantly moving. How fast are they moving? Pretty slowly, actually, around 1 to 2 inches per year, which is why it was so hard for scientists 100 years ago to wrap their heads around the idea. So what changed their minds? Well, a few natural discoveries in the 20th century made Wegener's theories seem more plausible. For example, in the 1950s and 60s, scientists discovered heated magma rising up through cracks in the oceanic crust called dikes, which is how new rock or new land is created. This realization that our planet is always reforming and reshaping itself from beneath lent credibility to Wegener's theories. Point Wegener. Not long after, scientists started plotting the location of earthquakes and volcanoes around the world and observed that the location of those events followed a similar pattern to the outline of the plates Wegener proposed. And then there was the fossil evidence. Fossils of tropical animal and plant species have been found in Africa and other places on Earth that are less than tropical. One plausible explanation was that Africa was once part of a larger continent that was home to these tropical plants and animals. Remember Pangaea? So in light of all this evidence, the scientific community started thinking maybe this Wegener fellow was actually onto something, which led to the development of our modern-day plate tectonics theory. So now that we know the history, let's dive a bit deeper into how it all works. According to the plate tectonics theory, these massive lithospheric plates are all moving in different ways, and how they interact with one another can have a huge impact on the Earth. Where these plates meet are called boundaries, and there are three kinds. Convergent boundaries occur when two plates are moving towards one another. Transform boundaries occur when two plates are sliding past one another, and divergent boundaries occur when two plates are moving away from one another. Let's take a closer look at what happens at each of these boundaries. As we said, convergent boundaries are when plates are moving towards one another. When the two plates collide, a couple of things can happen. One of the plates will dive under the other plate. It's usually the heavier, denser crust that dives under the lighter crust. This creates what is called a subduction zone. And the deeper under the Earth's surface that plate goes, the more pressure it creates. That pressure, coupled with a high heat, causes the crust to melt, forming magma. The magma presses up towards the surface, and voila, you've got a volcano. An example of this is the Ring of Fire, which is an active ring of volcanoes that encircles the Pacific Ocean. The other thing that can happen when two plates press into one another at a convergent boundary is the rock above the boundary will be lifted up or folded and form mountains. Ever hear of the Himalayas? That's an example of two tectonic plates colliding. And because the plates continue to move, the peaks in this mountain range continue to grow. For example, Mount Everest, which currently measures around 29,000 feet, grows around an inch every year. So as you could imagine, it takes thousands of years for these mountains to form. But although movement at convergent boundaries is usually gradual, as pressure underground builds, the impact above ground can be quick and violent. Fast movement or slipping of the land can result in earthquakes either above ground or under the ocean. And convergent boundaries aren't the only type of boundary that can result in earthquakes. At transform boundaries, the Earth's plates are sliding past each other in opposite directions, which creates a crack or fault in the Earth's crust. As the plates try to move, they rub against one another, resulting in the building up of pressure. If the plates are stuck for a long period of time, the pressure will continue to build at the fault line until eventually it releases, resulting in an earthquake. The San Andreas Fault System is one of the largest transform boundaries in the world, which is why that area has more than its fair share of seismic activity. That just leaves divergent boundaries. Like we mentioned before, divergent boundaries occur when plates are moving away from one another. Either the space between the two plates widens and becomes a large crack or rift, such as the East African Great Rift Valley that runs from Lebanon to Mozambique, or if the space between the two plates is under the ocean, where the crust is thinner, magma oozes up from the Earth's mantle and fills the space. This is called seafloor spreading. The Mid-Atlantic Ridge is an example of where seafloor spreading has occurred. The crust under the ocean pulled apart, allowing magma to fill the space between, creating the tallest and longest mountain chain in the world. So in review, the plate tectonics theory is based on concepts first proposed by Alfred Wegener in the early 20th century. It states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are always moving, leading many scientists to believe the continents we know today were once part of a supercontinent called Pangaea. These plates move 1 to 2 inches per year. Where they meet is called boundaries, and there are 3 different types. Convergent boundaries, where plates collide, transform boundaries, where plates slide past one another, and divergent boundaries, where they move apart. Volcanoes and mountains form at convergent boundaries. Earthquakes and tsunamis can occur at both convergent and transform boundaries. Fissures and large cracks in the surface occur when 2 plates move apart at a divergent boundary. And seafloor spreading occurs at divergent boundaries located at the ocean floor.
With this, we come to an end for this particular unit. I hope this was interesting and you have learned something new. Thank you, and remember to stay safe and stay indoors.